Base promoted cyclization of halohydrins. This class of compound is called halohydrins. It contains a OH group and a halogen group to the adjacent carbon. So this is halohydrin. Now if you remember Williamson ether synthesis, what happens in Williamson ether synthesis? We have an alkoxide ion, and if this is reacted with an alkyl halide, this gives an ether. Basically this is a open chain ether. Reaction follows SN2 pathways. Reactions happens between two molecules. So this is intermolecular in nature. So this is Williamson ether synthesis. Now base promoted cyclization of halohydrin is very similar to Williamson ether synthesis. Now this time we have this compound, that is halohydrin. If this is treated with base, now this base will take this hydrogen because this hydrogen is acidic. So if this base takes this hydrogen, this lone pair goes here, then we will have an alkoxide ion. So this is alkoxide ion. Now if you see, in the second step of Williamson ether synthesis, once this alkoxide ion is formed, we have a nucleophilic attack on an alkyl halide. This time we have alkyl halide in the same molecule, and alkoxide ion is also in the same molecule. So this part is alkoxide ion, and this part of molecule is alkyl halide. So SN2 attack in this case will happen in an intramolecular way. So if I attack intramolecular, so this O minus attacks here and X minus leaves. So we will have a ring. So we will have a cyclic ether. So you see, this reaction is used to prepare a cyclic ether. So halohydrins on treatment with base will give cyclic ether. So in first case we can say this is a intermolecular Williamson ether synthesis, and this one is intramolecular Williamson ether synthesis. So this is very similar to intramolecular Williamson ether synthesis. Now halohydrines can be prepared by alkene on treatment with water and halogen. So if I have an alkene, if this is treated with halogen, let us say chlorine, and water, it will form halohydrine. And mechanism is very similar. In the first step, we will have cyclic chloronium ion that is formed. So this goes here, this goes here, this goes here. So we will have cyclic chloronium ion. If I have bromine, then bromonium ion. So in general we can say cyclic halonium ion. Now this cyclic halonium ion is attacked by a water molecule in an anti-fashion. So if this attacks here, this goes here. So this attack is anti-attack. Here we have Cl, not OH. So this is Cl. And then we have OH2 plus. We can lose one H plus from here to get the final product, that is halohydrine. So if I follow this process, that is alkene on treatment with H2O and halogen, halohydrines will be formed, that is trans. So OH and Cl group are anti to each other. For example, let us say if I have this alkene, if this is treated with H2O and Cl2, we will have a halohydrine that contains OH and Cl are anti. Now when this halohydrine is treated with base, this will give epoxide. That is cyclic ether. Cyclic ether are also called epoxide. Generally in this reaction, base that is used is taken big one so that it cannot attack on this carbon. Now for halohydrine we have two possibilities. So let us say if I have a halohydrine OH, we have Cl. If I take a base, it can pull a proton from here or it can attack on this carbon. So there are two functions for this base. Base can pull a proton So we have base, it can pull a proton or it can attack on carbon to remove Cl. So this is the function of base, or you say function of negatively charged species. So generally we want to avoid the situation 2, that is, we does not want to attack on the carbon to remove chlorine. We want to act this negatively charged species as a base. So we generally take asterically hindered base. So asterically hindered base is generally taken so that it cannot act as a nucleophile. For example, generally this is taken as a base, that is 1, 2, 3, 4, 5, 6. So this is 2,6-dimethylpyridine. So this is taken as a base because of the steric region. So this can act as only as a base. It cannot act as a nucleophile. For example, if I have this compound and when this is treated with this base, that is 2,6-dimethylpyridine. So this is a 6-membered ring. So it will take a proton from here and this bond pair will go here. So it will form an alkoxide ion O-, and here we have chlorine, and acid base product we have nitrogen here. In the next step, this alkoxide ion will have intramolecular attack. So finally we will have an ether. So you see, base promoted cyclization of halohydrin gives ether. Reaction is SN2. Generally base is taken as asterically hindered. So we take an asterically hindered base so that it can only act as a base. It cannot act as a nucleophile. That is, it cannot attack on a carbon.